All right, let's look at example 211. We've got a particle moving along the x-axis, and its velocity is given by this equation. We want to find the net change in position, and we also want to find the total distance traveled during that period. And we want to do it by hand, and we want to check it using the Riemann sum calculator. So let's get started. Now, the net one is always easy to set up. To find the net change, we're just going to integrate from 0 to 10 our velocity, t squared minus 8t plus 15. And doing this by hand, we'll get 1/3 t cubed minus 4t squared plus 15t, going from 0 to 10. All right, if I plug the 10 in, I get 1/3 of 1,000 minus 4 times 100 plus 15 times 10. And let's see, what is that? 1,000 over 3 minus 400 plus 150. That gives me 250 over 3. Or if you write that as a decimal, it's 83.3 repeating. All right. Let's check that on Desmos while I've got it up. Or I'm sorry, not on Desmos. I'm going to check it on my Riemann sum calculator. So basically, we're doing the function x squared minus 8x plus 15. So we're looking at that function. And we're supposed to go from 0 to 10. And I've got it currently using 50,000 rectangles, and it's giving me 83.33. So that looks pretty good. Now, to do the other part, to do the total distance, well, what we've got to do is we've got to account for the times when it's moving forward and backward. Let's look at this for a second. If you look down here, you know this the little parabola there tells us the velocity of the thing. When we go from, I can't really point to it on here, but if you start at 0 and you go to 10 on there, you'll notice from let's see, from 3 to 5, the between 3 and 5, the velocity is actually negative, meaning it's moving backward. So if you think about what's going on here, the particle starts somewhere. We don't really know where, but it starts somewhere on the axis at t equals 0. And it's moving forward until at t equals 3, it stops moving. It stops moving, and then it starts moving backward. It moves backward until t equals 5, and then it moves forward again. And so when we're looking at this, when we're trying to find the total distance traveled, we have to account for this zigzagging back and forth here. So the first thing that we should do is figure out when does this thing stop, but honestly the graph's already given it to us. If you look at this, we should set this equation equal to 0 and solve. Well, looking at the graph down there, we can tell that it's equal to 0 at 3 and 5. So to do this total distance, what we want to do is we want to integrate from 0 to 3 with v of t. And then we also want to integrate from 3 to 5. And then we want to integrate from 5 to 10. Now, if you look at that and you look at the, let me turn these rectangles back on. If you look at these areas, they're given to us by the those red rectangles. I mean, they're so small you can't even see them. But if we look at that, 0 to 3, this is it's moving forward here. So that's that first part of the graph. down there. The first part where it's positive. From 3 to 5, that's the slim little bit, again, I can't point to it, but in the middle there, where it's below the axis. And this corresponds to the area above the axis, and that big thing that looks kind of like a curved triangle. Yeah, don't tell your friends that your math professor said a curved triangle. Anyway, this right here will give it to us. This gives us the, well, it almost gives us the total distance. We've got to make all of them positive to get the total distance. So look, here's what we're going to do. This is going to be f of 3 minus f of 0. This is going to be f of 5 minus f of 3. And this is going to be f of 10 minus f of 5. Where this big F is just the antiderivative. Big F of t is the antiderivative we found up here. This. Sometimes I wonder how I ever taught on a whiteboard where I couldn't move things around. All right, so let me get rid of the graph for right now. So now we've got to work out what these things are. We've got to plug all these numbers, 0, 3, 5, and 10. We've got to plug all those into here. I don't want to do that. So here's what I'm going to do. I'm going to make a chart. T and big F of t. 0, 3, 5, 10. And I'm going to let Desmos do the work for me. Let's see. Well, this is not it. I've got to type it in. 1/3 t cubed minus 4t squared plus 15t. All right. Now f of 0, we know that one's 0. F of 3 is 18. F of 5 is probably going to, f of 5 is going to be a fraction. 16 2/3, that's 50 over 3. Yeah, 50 over 3. And 10 is going to give me a fraction too. I'll put in 10, that gives me 83.33, so 83 plus 1/3 is 250 over 3. So I'm going to take these numbers, plug them in up above, and that's going to give it to us. So f of 3 minus f of 0, that's 18. F of 5 minus f of 3, 50 over 3 minus 18 is negative 4/3. And then 250 over 3 minus 50 over 3 is 200 over 3. And we're supposed to be absolute valuing all these things. So if I add these three guys up here, that's 18 plus 4 over 3 plus 200 over 3, which gives me 86. So 86 is the total distance traveled. So we could go through and work out how basically the difference in this 83.3 and 86, the difference is this little distance here in the middle where it goes backward for a little while. Notice when you're counting the entire, when you're counting the total distance, you wind up counting that bit 3 times. Once, twice, and then again. So really 2 times this, that's going to be the difference between these two guys. But I said we were going to do this with the computer, so let's do it. If we go back to the, if we go back to this and look at it, this is that gave us the net amount. To get the total amount, you just put in ABS for absolute value around this. Hit enter, and it gives me 85.998, which is real close approximation to 86. All right, so that does it for this example.